Right. Okay, the cluster is configured. We are able to access it using admin.conf, but now we have to access the cluster using our user credentials. Now, in order to do that, we need this information. Where did it go? I think I closed the tab. So let me run the curl command again. Okay. So here, this is the refresh token. This is the ID token. Okay. So these two tokens are required for us to, uh, authenticate with it. And the authentication documentation itself tells us about how we can uh, authenticate. So first, let's create these credentials. Okay. So let me copy this whole thing. Okay. So let's copy this, keep it inside my cluster here. Now I don't need this token anymore. It's useless because I don't have the refresh token. I have this, but other information also which is important, I better copy it, which is kubeadmin join. So in case we want to join this in a cluster, this is very important. So I'll just make a copy of it and keep it here in the file for the time being. Okay. Now auth provider OIDC, fine. Auth provider issuer URL. Okay. This will be the same issuer URL which we configured on the server. Where did it go? Here. So here is the issuer URL. Copy link and paste it here. Client ID is Kubernetes -client. Client secret, right now it is public, it does not require any client secret. We'll remove that. Refresh token, so let's copy the refresh token from here. Yeah, so this is a refresh token, copy it, paste it here. Certificate authority, we don't need this, or okay, we need it. This is our, wherever we are running kubectl, that needs to have access to Keycloak's CA, Keycloak certificate. Okay, and this we can, since we are running Keycloak inside this, the location would be vagrant certs tls.crt. Okay, so let me copy this and keep it here, and then we need the ID token. So here is the ID token. Let's paste it here. Okay, so there we go. Now, yeah, so this is the command which we are giving. So this is a kubectl config set credentials command. What this is going to do is, okay, it is setting credentials for some user called mostly. We'll use this admin. Okay, so what this is going to do is, this is not going to talk to the server at all. This is going to change, or this is going to create a config file. So if you see ls.kube, this does not have any config file here, right? So the set credential is meant for setting this credentials for admin users in the configuration file. Okay, let's execute this and verify that it has done so. Okay, so it says user admin set. Now if I say ls .cube, you can see this config file is created, and if we say cat .config, you can see the same information that we provided: the ID token, client ID, IDP, the refresh token, IDP issuer URL, and the certificate authority. All this have been set here in the config file. Okay, having set this in the config file, okay, now we have the credentials. Now we also need to configure the server here. Remember, in our cluster.yaml, we have provided the bind port to 6443. So our server can be accessed with this IP address and this bind port. Okay, so let's say kubectl config set cluster. I'll call this cluster as C1 and set the server to https 192.168.100.11:6443. Okay, we also have to set the server TLS. And where do we get the command? So there is documentation for this also. It's Google for Kubernetes multiple clusters. Configure access to multiple clusters. So this tells you about how you configure your kubeconfig file. Okay, so here is an example of how you can connect to a server. So in addition to server, we also need a certificate authority, and this is not Kubernetes certificate authority. This is the certificate authority of the Kubernetes server itself. And here we are going to provide the path of etc kubernetes pki ca.crt. Okay, so this is, we have created a cluster, we have a user, we have a cluster. Now we have to make sure we use that particular user for that particular cluster. There could be multiple users, there could be multiple clusters in the configuration file. And the way we do that is by defining a context. So context is a mapping between a user and a cluster, right? So we can create a context by saying kubectl config set context c1 context, which is the name of the context, and then provide the cluster information and the user information. I'll say cluster is c1 and user is admin. Okay, so context c1 created. Now we have to use this context. So kubectl config use context c1 context, and we can verify what context is being used. Kubectl config current context. Okay, so c1 context is being used. Okay, all this information, kubectl config commands, it's only going to modify our config file. So all the information we provided, the cluster information is here, the context information is here, the user information is here. Okay, so this context is for cluster C1 and user admin, right? All fine. Now we'll try to connect to the server. Kubectl get nodes. Okay, so what happened? Error from server, nodes is forbidden. User admin cannot list resource nodes in API group. So the important thing to notice here is the API server is responding. Okay, the client is able to send a message till the API server. So the authentication is happening, but the authorization is failing, which means this user admin does not have access to do get nodes on this cluster. Okay, now how we normally solve this is by creating a cluster role binding. So let's see how we can create a cluster role binding in Kubernetes. Okay, so here is a sample YAML for this. So let's create a cluster role binding.yaml and keep this information here. Okay, so kind role binding, no, I want a cluster role binding, not a role binding. So the example for that is here. The files are mostly same. If you see, the only difference is this kind here. So let me try by changing this. It should work. And metadata is for cluster admin. Subject kind should be group. Name of the group, this is important. The name of the group would be Kubernetes admin. Okay, remember how we have arrived at this name? due to prefixes at two different levels. One is in Keycloak itself. The token itself comes as Kubernetes admin, and then when configuring Kubernetes, we asked it to add one more prefix of Kubernetes, right? Then the API group. The API group for API server is basically an empty string. So actually, yeah, API group of this. Okay, let's try this first. So role ref kind is not role, kind should be cluster role. Okay, and okay, and group here also we should not use a name, we should actually use a ref. So let me use a proper format here. I actually have this file written, so let's just refer to that. Vagrant samples OIDC cluster role binding. Let me copy this to the current directory. Okay, so metadata name is there, Keycloak admin group, role ref, API group is this, kind is cluster role, name is cluster admin, subjects. So this is a role. Cluster admin is a role that is already available in the system. Okay, I'll show you that. And the subject is basically this group of Kubernetes admin. Okay, so this group we are giving the cluster role. We are adding him to this role, cluster role. Okay, and let's apply this. kubects we have to apply using the admin config. So kubeconfig admin.conf -f, sorry, apply -f cluster role binding. Okay, so it created this cluster role binding. Now if we say kubectl get nodes, you can see that it works. kubectl get nodes is using the configuration file which we gave, which we created just now, right? Whereas this admin conf, it already had the access, right? So using this admin conf, we added the new cluster role binding, and now we are able to access this. Now, I said I am going to show you something. Yeah, I said that I'm going to show you the list of all the cluster roles which are already available. So kubectl get cluster role bindings. Okay, so these are all the cluster role bindings, and the one which we used is this one, cluster admin, right? So this role binding along with the necessary permissions are already there. So we have just used the same thing. Now, in a practical scenario, what we would like to do is we would not give the complete cluster administration access to everybody, to all users. So we will give them only access to only those resources and those namespaces which they require. So and also there are certain resources that we can create here. There are resources such as role and role binding. Okay, so when we create a role, this has to be created as part of a namespace in Kubernetes. So all the permissions which are applied using that role is applicable only within that namespace first. Okay, and in order to assign users to that role, we have to create a role binding. Okay, so role and role binding works within a given namespace. Whereas when we are working with cluster role and cluster role binding, then we are actually working across the cluster. So because we have given a cluster, we are using this cluster role. So we can say kubectl get cluster role. Actually, this is a role binding. What we gave access to was a cluster role, not a cluster role binding. So this cluster role, cluster admin is what we have assigned to that group, not the cluster role binding. Cluster role binding is something which we created, and what was the name of that? Let's verify. cluster role binding.yaml. The name we gave here is Keycloak admin group. So when we look at the list of cluster role bindings and grep this, we should get the newly created cluster role binding. Okay, so this cluster role binding, if we print out the YAML, is what is binding the user. Okay, yeah, which is binding the subject, this group, Kubernetes admin, to this role of cluster admin. Okay, so using this mechanism, we can define groups within Kubernetes, and we can define groups and roles within Keycloak. So there are totally 3 groups and roles that we are dealing with. The first one is cluster role and cluster role bindings in Kubernetes. Then we are dealing with roles and role bindings within namespaces within Kubernetes, and then we are dealing with users, groups, client roles, and realms inside Keycloak. So if we are familiar how to use all of these things, then perhaps we can administer this cluster very smoothly. Okay, and when it comes to creation of users, all we have to do is in Keycloak, there is a users tab here. We can very easily create users here. So add user and you'll be able to create a user. Okay, and in case you want to add a realm, like for instance, there are different types of people. For instance, if you want to create a multi-tenant identity provider, maybe you have different clients and you're providing access to different clients. So for each client, you can create a realm over here. So that is something which we can do, just so that you don't mix up all the users under a particular realm. So yeah, so that's all about this video. So what we have seen is we have configured Keycloak, we have configured Keycloak with a self-signed certificate, we have seen how to configure Kubernetes with kubeadm command, and then we had configured OIDC as Keycloak as an ID provider, OIDC ID provider to our Kubernetes cluster when we are initializing it. And finally, we saw how to use how to create a kubectl configuration file for a particular user, right? And we also had a very brief introduction about role bindings, cluster role bindings, and a very brief introduction about Keycloak, realm, clients, groups, users, and client roles. Okay, so hope this was useful. In case you have any questions, then please put it down in the comments. And yeah, thank you. Thanks for your time.